So we've spent a great deal of time talking about protons and neutrons and electrons and how you can go about figuring out how many valence electrons something has and using that to determine what kinds of bonds it might make. But frankly, it's a pretty unwieldy little bit of knowledge that we've gained there. And like, let's say I wanted to figure out, well, chlorine, it's got 17 protons because, well, that's its atomic number, so it's a neutral atom of chlorine is going to have 17 electrons. Okay, let's put 2 in the first, 8 in the second. It's going to take a long time for us to figure out how many valence electrons it has, what kind of bonds it's going to make. So we're going to shortcut that here, and we're going to figure out a much easier way to determine valence electrons. So over here, we have this first group. Remember, these things are all similar to one another. They have similar properties. That's why they're arranged this way. But this first group all has one valence electron. The second group here, well, they all have 2 valence electrons. And this periodic table has been showed with the lanthanides and the actinides and all the transition metals. We're just going to go ahead and skip those. We're going to skip right over those, and we're going to go to the next high column here. These all have 3 valence electrons. So group 13 has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5. Group 16 has 6. Group 17 has 7. And group 18 has 8. Remember, those are the noble gases. Their valence shells are full. They don't interact with anyone. Their octet rule has been fulfilled. So let's do that one more time. How many electrons in this first group? 1. How many valence electrons in the second group? 2. Skip a few. How many valence electrons here? 3. How many valence electrons here? 4. 5, 6, 7, and 8. So there's a couple of exceptions to this. Remember, helium only has 2 valence electrons, but that's okay. That's an easy one to remember. It also has a filled up outer shell, and so you're really not going to see it reacting with things very much. So even though it only has 2 valence electrons, it still has a fulfilled octet. It's still not reacting with many things. Let's look at iron. How many valence electrons does iron have? Well, we're not really sure because it's in this transition group. So 1 valence, 2 valence, skip a few, 3 valence, 4 valence, 5 valence, 6 valence, 7 valence, 8 valence, fulfilled octet.